what I'll do, so I included it in the email, is I'll send what we're gonna do next time in there, and you can take a look at it, and if there's stuff like you think you'd be okay with, or we can skip over that, and then stuff that you're not sure about, we can go through that stuff.
Yeah, yeah.
Okay, so yes, so stats, measures of central tendency. All that means is averages, so like mean, median, and mode, and they'll just kind of take it to the next level for A level. So you've got mode, modal class interval, all that stuff, median value, and then they will use this notation. So sigma x over n. Sigma x just means the sum of all the x's. So what you get when you add up all the numbers, and the average, like the mean average, they write as x bar. So if you see that x with a bar on it, that just means the mean average. Yeah, sigma x just means they added up all the x's, and then n is the number of values. And sometimes you have to do it in reverse. Let's try this one. How do we do this?
So I'm guessing this will after the sigma x thing.
You could. A few different ways to do it. So this time they tell you the average, and you have to find the overall average. So the mean of 25 things is 6.4, and then the mean of 30 things is 7.2, and you have to find overall what the mean is.
I have to do 25 times 6.4 plus 30 times 7.2 divided by 55.
Yep, 25. So, you want to put that in your calculator, see what you get? 5 times 6 plus 4. 30 times 7.2 over 55. Oops. Did you get an answer for that one?
Um, I got like 6.83, 6.84, sorry.
Okay,
Yeah.
so yeah, 3 sig fig. That is 6.84 and 6.84. That's it. Great. I think you're good there. What is this one? Mode. Yeah, so mode you can use for qualitative data, so words and stuff. Median. Uh, yes, median, the benefit of it is it cuts out extreme values and outliers. And then the benefit of mean is it takes all the data into account, but unfortunately it's affected by extremes. In frequency table, it's sigma xf, meaning the x times the frequency, and then you add them all up over total frequency. Okay. Okay, this one, mode.
Okay. So will the mode just be like 16.5?
Yep, that's it. How about median?
Is it why I actually have to like put them all in order now?
They're already in order. So if you were to write these out the long way, it would be like 15, 15, 15, because there's three of those. Then there'd be 17, 15.5s, and so on.
Yeah.
And so any idea how you find median from a table?
We'll have to do something like 15 plus 17 divided by 2.
The way I would do it is cumulative frequency. So we started with 3 students, then the next would be 20. And what was the rest?
49.
Mm-hmm.
83. 95.
And so there were 95 students. You have to find the median student.
So should I separate that into like quintiles or something?
You just need to find the middle one. So for the median, it's going to be the medianth person will be n plus 1 over 2. And in this case, n is 95.
N plus 1 over 2. So 48.
And so that means it is the 48th person. And so what shirt collar size has the 48th person?
16.
And so the median is 16. So mode was 16.5, median is 16. And any idea how you find mean from a table?
Would I just do like 3 times 15 plus 17 times 15.5 plus 16 times 29?
Yep.
Plus 34 times 16 plus 12 times 17 and then divide that by 5.
Yep. Hang on, not divide by 5. There's 5 categories. You'd divide by total frequency.
Yeah, sorry. So divide by 95.
Yeah. Did you get an answer for that one?
I got 14.90, but I might have just written it in wrong, I think.
So I got 16.18.
Yeah.
And so we'll see. So that seems 16 seems all right because the first one was 16.5.
Yeah.
The second one was 16. So yeah, it might just be some input thing. So let's take a look. So mode highest frequency 16.5. The other one 48th person n plus 1 over 2 median. And so that was person 48. So they had 16. And then x bar x times frequency, sigma x times frequency over n, and it goes to 16.2. And what is part D?
Because that's the size they'll make the most profit from.
Why is that?
Because if they've sold the most shirts in that size, they've made the most profit from that size over the others.
That's it. Why would they not use the mean?
Because the mean just tells them the average of the shirt size. It's probably not like useful information for them.
So basically there is no size 16.2.
Yeah.
shirt size is discrete data. It's like shoe size. Even though they have like 15.5, there's no 15 and 3/4 or anything. There's no
Yeah.
16 and 1/4. Yes. Let's just see what they said. The mode is an actual data value and gives the manufacturer information on the most common size. Yes. Now, let me see. Menu. Is it statistics? Yeah. Menu statistics. One variable. Do you have frequency switched on? So menu statistics, one variable.
So sorry, statistics and then one variable. Okay, I've got it now.
And do you have frequency on?
No.
Just X. So I think it's shift menu for setup.
Yeah.
Uh, maybe it's down and then 3 for statistics. Yes.
Sorry.
So
So shift menu.
so shift menu for setup. Press down, and it is number 3 for statistics.
So I didn't see setup.
So you press shift before menu.
Yeah.
So shift menu, and that gives you the setup menu.
All right. Yeah. And then what do I press here? Sorry.
And then it's down, next one for statistics, number 3.
Yeah.
And frequency, switch that on.
Yeah. I've done. Yeah.
Okay, and so that's going to be that'll be in the memory now. You won't have to do that every time. That's just done. So menu statistics, one variable,
Yeah.
and it will be X and frequency. Put the table into your calculator. So our calculator goes down, their table goes across, but it's the same thing. So X was the collar sizes, and frequency was number of students. 5. So 15, 15.5, 16, 16.5, 17. And then you press right and down to go back to the top, and then frequencies. And match the frequency up with X.
Okay. Yeah.
And then I believe it is option. So this one under the shift button. Option. I think it's 3 for one variable calculation.
Okay.
And they give us a bunch of stuff. What's this thing up the top, the first one?
That'll be. Is that on mean?
Yeah, so that's X bar. So that's the mean. Sigma X is what you get when you add up all the X's. Sigma X squared is what you get when you add up all the X squared. You've got standard deviation squared, standard deviation, different stuff that we'll look at later. Press down,
Yeah.
and you can see there you've got Q1, median, and Q3. So like lower quartile, median, and upper quartile. The median, it says, is 16, and our median was 16.
Yep.
It says N is 95, so 95 students. So that gives us the total cumulative frequency. So the good thing about using that is, so one is you can kind of check that you've inputted it correctly. Like it'll say 95, that matches with 95, and also you won't. It means because you're very likely to make a mistake when you're putting in this like long way of doing it.
Yeah.
It's very likely to make a mistake. Now you might need to know that for solving some algebra or something, but if it's just find the mean, the calculator, it means you won't make a mistake with it. So any questions about that calculator stuff or that question in general? Okay, gives you minimum and maximum. Okay. Let's see. Okay, exam question. You'll be fine for that. Okay, so let's try this exam question.
I'm guessing I can just put that into my calculator, can't I?
Yeah, and they're both one markers. They're all one markers, and so there's no extra marks for showing working out. It's just to get the right answer. So put it into your calculator. Let's see. I don't know. Exit, is it? Yeah. Tell me if you're having difficulty finding those.
Yeah.
That's the screen.
So it gave me a median of 6.
Say it again, sorry.
It gave me a median of 6.
Okay, so median is 6, and it says calculate the mean.
It says it's like 5.7778.
So 5.7, let's say 5.78.
Yeah.
And question C.
I mean, I need to add one more 7 to the frequency, so now it's like 12 sevens rather than 11.
12 sevens. Yep.
Yeah. So the mean will just go up to like 5.8ish rather than 5.7. The mean will increase basically.
Go on, what is it exactly to 3 sig fig?
It says it's 5.796. So is that like 5.88 basically?
Yeah, you'd write it as 5.80. So you've shown that it's that to 3 sig fig.
Yeah.
Yeah. So basically, yeah, the mean increases, and that's because 7 is bigger than 5. The mean 5.78.
Yeah.
But I like your way of doing it. You just put it in. Just put it in and see it. So yeah, it will increase. So 6, 5.7, 8. Great. Any questions there? So this is just about putting it into this. Okay, now we have grouped data. How do we do this?
So that would be 6 T and 8, 6 T8 or so.
Yep. T is between 6 and 8. How do we do an estimate of the mean?
But I just do the middle of the time.
Yep. So what goes in for the first one?
Would it be 3?
Yeah. And if you're ever stuck, you can just do, I'll just do it in brackets, the lower bound plus the upper bound, close the bracket, and divide by 2. So you can put it in the calculator. So it's 3. It's obvious for that one, but if it's not obvious, you can just add the 2.
Yeah.
Divide by 2. So it's like the mean of that.
Sorry. So 3, 5, 7, 9. And it gave me an estimate mean of 6.
Estimated mean of 6. So x bar equals 6. And again, the first one was a 1 marker. This one is also a 1 marker. And so you don't have to show working out, and you're not missing out on any marks by doing it this way. Yeah. And question C.
So it's an estimate because I've just taken the middle out of each number.
Yeah. The midpoint is an estimate. The midpoint has been used to estimate the time each customer in each class interval has spent in the store. So basically, these first 7 people, we know they did something between 2 and 4, and we just said all 7 did exactly 3 as our estimate. So maybe they did 2, maybe they did 4, maybe they did like a mixture of all of them. But yeah. Any questions there?
No.
Okay, that's good. Yeah. So you just take the midpoint for the mean. Modal class, estimate the mean. That's good. Let's see this one. Yes, there's a little trick to this one, I think. How do we do this? So part A, modal class.
So should I just take the middle of the length of the pine cone again?
Modal class.
Oh, sorry. So yeah, 34 to 36.
Yes. So then part B is asking for estimate the mean. So there's a difference here. These are X millimeters long to the nearest millimeter. So what group would a pine cone be in if it was 31.1 millimeters long?
Would that be like 31.25 or something? Oh no, sorry. 35 point. No, sorry. Sorry. If it was like 35.1, would that be like 35.15 and 35.05?
What do you mean, sorry? So imagine I just found, do you remember they said there's an additional one. What will that do to the mean?
Yeah,
A while ago, and you just said you just put an extra frequency. Okay, so I pick up a pine cone, an extra one, and I measure it on my ruler, and it's like 31.1 millimeters long. What group does that go into? What frequency gets increased?
None.
Yeah, because it's kind of in between these two.
Yeah.
So these categories are rounded to the nearest millimeter. And so if you were rounding it to the nearest millimeter, what category would it go in?
30 to 31.
Yes. And so the way you go about this is you unround the categories. And so you do the lower bound and upper bound for each category. So for the first one, 31.1 would be included. And so what would be the lower bound and upper bound for the first category?
So lower bound would be 29.5.
Mm-hmm.
And upper bound would be 31.5.
Yeah. So for this one, what is the midpoint?
30.5.
So the midpoint for this one is it 30.5?
Yeah, I think so. Yeah.
You think so? Hang on, you're smarter than I am. So let me just make sure. Delete. So I do my thing. 29.5 plus 31.5 close bracket divided by 2. So 30.5. So okay, maybe that'll be the same for the mean. Okay, and then we have to. All right, well, so let's estimate the mean. Then put that in your calculator. See what you get for the estimated mean.
So, sorry, am I putting midpoints of each of the lengths of the pine cones here?
Yeah.
After down the up, down, lower bound. Yeah.
Yeah, so just the normal way, calculator,
Yeah.
get the estimated mean.
So, I've got mean of like 35.54.
Okay, so 35.5 to 3 sig fig,
Also, no, 34 point, sorry, 34.5.
34.5, sorry. And then C, median.
So the median that will be 35.
And the median is 35. We're saying median is 35. Let me see. Or I suppose, so they're just giving it as this. The mean is 34.5, and then the median is in the class of 34 to 36. And so we're just saying that as 35. That's okay. Okay, that's good. That's okay. It's not what I thought it would be. This one, that's gonna be fine. Write down the modal class estimated mean. That's fine. So we can just keep using the thing. Yes. So what do you give yourself for that stuff?
I think overall maybe a tick, yeah.
Okay, other measures of location. So we looked at median, but you can also do lower quartile. You can also do upper quartile. You can also do anything like 10%, 85%, 15%, anything like that. Anything at all, if you think about it. So to find the lower quartile for discrete data, it's a quarter of n. It's that value. And then for the upper quartile for discrete data, it's 3/4 of n. That value. Okay, how could you find the median and quartiles for this data?
So I don't need to put this into like. Oh wait, would I need to put this into like a frequency table or something?
You could. So 17 has a frequency of 2. So if you were doing this at GCSE, how would you find median?
I'd probably just line them all up or something.
So these are smallest to biggest. They couldn't fit them on one line, so they kind of went on to 2. But it's basically the first 10 on the top, second 10 on the bottom.
Oh no. Oh wait, I was trying to find the median. Sorry.
Yeah.
Would you find the middle of the entire set
Yeah.
like middle position, and then just like count up to that place or something.
Yeah. So the middle will be in between 22 and 23. And so
Um, 10, will that be 22.5?
So that's 22.5. How about lower quartile?
So that'll be so if the first so do I need to do 10.5 divided by two or something?
You would have to do 1/4 of 20.
Yeah. So the fifth is that the fifth position?
Yeah.
Yeah. So 18.
Yeah. And upper quartile.
Um, that would be 3/4 of 20, 15.
Mm-hmm. So it'll be the 15th value. Which one is that?
25.
Okay, 25. So now I want to try your thing, putting them in a frequency table. And I'm just going to do it. I suppose I could do the frequencies. I'll just do everything with a frequency of 1. 19, 22, 22, 23, 23, 23. Just so I don't make any mistakes. 27, 28, 36, 39. Option this thing. So Q1 18, median 22.5, and then Q3 25.5.
Yeah.
Hang on, Q3 doesn't match up, does it? 3/4 times 20 is the 15th value. And the 15th, that's 10, 11, 12, 13, 14, 15. So we're getting 20, we're getting 25 for that one. Let's take a look. 25.5. Why is that? Oh, that's why. Hang on. It's because this is continuous data. Maximum daily gust in knots. So wind speed. So speed is what do you call it? Continuous. And so for continuous data, the lower quartile is n plus 1 over 4. The upper quartile is 3n plus 1 over 4. Like 3/4 of n plus 1. So it's not just n, it's n plus 1. So 3/4 of n plus 1. And so it would not be 25, it would be between 25 and 26. And they just said 25.5. And our calculator counted it as continuous data. Calculator just defaults to continuous data. Okay. So for discrete data, like shirt collar size, it's just n over 4, 1/4 times n. Whereas for continuous data, like speed, it is n plus 1 over 4. So you add 1 to the total n. So this would be 21 over 4, which was still in between 22 and 23.
Yeah.
So any questions about that? Okay. So now it's about to get a whole lot harder. The way they estimated this, so the Q hang on a second. So Q1 okay, I'll just go for it. So interpolation, instead of taking the number that's right in the middle of the two numbers, you can say, well, if my thing is 3/4 of the way along, then I might take 25.75 as a better estimate. Or if it's like 9/10 of the way along, you might say 25.9 as a better estimate than 25.5. And that's called interpolation. So this one, find an estimate for the upper quartile. Any idea how to go about that? Upper quartile.
So would I have to get the upper and lower bounds of the sets first?
Yeah.
So first one would be 29.5 to 31.5.
Okay, so I'll put in all those.
Yeah.
5 to 25, 30, and then okay, what do you do after that?
So um would the upper quartile be like 3/4 of 29.5? Or
Um, um, why 29.5?
okay, 39.5. Sorry.
It would be, in theory, 3/4 of the total frequency.
So I need to add up the frequency and then times that by 3/4.
And the way I would do it is do it as cumulative frequency. That'll be helpful for later.
So 227, 57, 72.
That's it. And so, what position is the upper quartile?
52.5.
So the 52nd point fifth value. And
Yeah.
so, what can you do with that?
So did that tell us the
So what is the 52nd point fifth value?
that's in the 30, 34, 36.
Yes. So an estimate of the upper quartile is 34 to 36. A better estimate would be what?
35.
So a better estimate would be 35. So now, which would it be closer to? 34 or 36 if it was the 52nd point sixth value? So 52.5 is pretty close to 57, which is the very end of this group. And so would it be closer to 34 or 36?
Sorry, I didn't. Sorry, I didn't.
So you know how like the first two are 30 to 31,
Yeah.
and then the first 27 are 33 or less. So like uh, the like student number 28 is the very first in the third group. So his time, like student 28, his time would be close to 34. And then student 57, his time would be close to 36. And
Okay.
so if you had student 52 or 53, would his time be closer to 34 or 36?
Mm. I'm not sure.
So student 28 would be close to 34.
Okay.
Student 29 would also be kind of close to 34, just not as close as the previous one. And then student 57 would be very close to 36, because that's like at the end of that group, because you're putting all these kids from like slowest to fastest, so smallest to biggest numbers.
Yeah. Yeah.
And so basically 52.5 is closer to 57. So 52.5 will be towards the end of the group. Like of those 30 kids, so like 57 cumulative frequency up to that point, 52.5 is pretty close to the end of that group. So they'll be
Yeah.
closer to 36 than they will be to 34. So the way we said our estimate is 35, a better estimate could be like 35.5, something like that, because it's going to be closer to 36. But there is a way that we can actually calculate it. And so now we are going to calculate it. So I'm just going to use, I used to use a different method that was like kind of intuitive. I just want to use a method that you can like use your calculator for, and you might not understand it, but we'll see. So if we split this group up and we say so Q3 was the middle one. So let's see. So this starts at 33.5. So 33.5. And that was the 27th student. Let me put it the other way around. So 33.5. And so the 27th student, we're saying 33.5. The 57th student, I think it was. So the 57th student would have gotten 36.5 as their as the upper bound. And so Q3 in the middle is 52.5th person. So far, so good. Do you see what's going on there?
So
So,
I'm a bit confused. I think so. I see the upper bound and the lower bounder here.
yeah.
And I see the quartile.
So that's the lower bound. So the lower bound, so the 27th kid, he's at 33.5. 57th kid, he's at 36.5. So those are the lower bounds and upper bounds. And then Q3 kid is the 52nd.5th. And so Q3, so the difference between Q3 and the lower bound, as a proportion of that, you've also got the other side. So the difference between the upper bound and the upper quartile as a proportion of 50, the difference from 57 to 52.5. These two will be equal, and you can then use your calculator to solve that. Let me just make sure that I've put this in right. 52, they did it slightly differently. Let me just make sure. Q3 minus 33.5, 36.5. So that's 57, that's 27. They're using the whole group, is it? Oh, I tried this new method. Let me see. So this distance here, 30 Q3 that over 36 over that total is this part out of this total. Okay. Hold on. So they're taking the whole thing into account. That's going to be a more accurate estimate. We want the most accurate one. So, yes. So from Q3 to the lower bound, or the lower bound to Q3, out of that total, so 36.5 to 33.5, will be the same as for the bottom one. So the 52nd.5th to the 27th out of that total. 57 minus 27. Let me just make sure. So Q3, 33.5, 36.5, 33.5, yes. 52.5, 27, 50, yes. So, and you can now put this into your calculator with X and get the answer that way.
Okay.
And so it's going to take practice. This is something that like most students get wrong come exam time, and with good reason. Try putting this in, see what you get.
Yeah, I'll be closer.
You got 36.05.
Yeah.
And so, let's just go back a second. So our first estimate, so basically it's 3/4 of the 70 people. It's person 3/4 of the way along. And it's the 52nd.5th person. So our estimate is 34 to 36. Our better estimate is 35. But our even better estimate still is this person is towards the end of this group, like 52, 53 out of 57. And so it's going to be much closer to 36 than it is to 34. And actually we extended it to 36.5 and 33.5. And it turns out it was 36.05. So that's a much better estimate than this one. And it's essentially, you can imagine like 52 out of 57, something like that. 52 out of 57 times times this group, like that as a fraction. So this is just a very rough estimate. 52 out of 57 is like 91% of the way along. So our estimate of like 50%, the middle one, a much better estimate would be it's like 90% of the way along, which is 36.05 out of that 36.5. And it is following this thing here. So this part, so it's this fraction out of the total, this fraction out of the total, and those two are equal to each other, and that gives you an equation to solve it. So any questions about that bit?
No.
So now let's try it again, but with the 10th percentile. So, oops, do that there. So how can we do this with the 10th percentile?
So so do I need to do 3/4 times 70?
That would be the 75th percentile. We want the 10th percentile.
So I need to do something like 0.1 times 70, or
Yep.
so that would be 7.
So it is the seventh person, seventh value.
Yeah.
Okay, what's next?
Um, do I actually need to like go along this to the 7th value, or
So where would the seventh value be? Where would it fall into?
32 to 33?
Yeah. And so that group, we had to extend that to be that one. So we know the seventh value is somewhere in there. And this is the 10th percentile. I'll just call it X or something. 33.5. Okay.
And then is this where I put them to the frequency table or not yet?
This we won't be able to use frequency table for this because it's
Oh,
estimated data, it's rounded data. Which person is 31.5?
um,
So we can't
so
know
they,
for certain, but if we were estimating this out, so these first two people, first group, which person would have spent 31.5 minutes out of the 70 kids? Which kid number spent 31.5?
um, probably number 2 or number 3.
Number 3 is correct. How
Yeah.
about 33.5?
I'm guessing 28,
27.
27. Okay.
So it's just up to that one. And this was the 10th percentile. And so let me go back to our one that we did. Q3, 10th percentile. So this was the 7th kid. Yes. So third was 31.5. 27th is 33.5. And so 7th kid is what we want to find. How do we do that?
Sorry, what were we trying to find? Sorry.
We are trying to find an estimate for how much time the 7th kid spent on the internet. So the third kid spent 31.5 minutes. The 27th kid spent 33.5 minutes. How much time did the 7th kid spend?
Okay. And is this where we have to use the little formula with like
Mm-hmm.
Q3 and stuff?
Mm-hmm.
So is that 5?
Can you say it again, sorry?
Is that, sorry, 33.5? Or sorry, whatever Q3 is minus.
So X minus.
Sorry, can you remind me of the formula, please?
So it will be this bit of the part out of the total. So X minus 31.5 out of 2. So 33.5 minus 31.5, the class width.
Yeah.
And any idea about the second bit?
Uh,
It's essentially just the same but for the bottom.
so is it just equals to 33.5 minus 31.5?
the bottom of this part down here. So do the same
Oh,
thing for those because they match up with each other.
so is that 7 minus 3
Yeah.
over 27 minus 3?
Yep.
Okay. I got like 31.8333.
So 31.8 minutes, and they rounded it to 31.9. Let me see. Minus 31.5. 33.5 minus 31.5. Yeah. 7 minus 2. 27 minus 2. Why did they do 2 instead of the third person? The seventh value. Why did they do 2? Let me just see. Did they explain that? Why did they do 2 instead of 3? This one is matching up that way. Oh, we'll see. Okay, any questions about that?
No.
That's weird. I'll have to think on that one. Okay, exam question. Estimated median.
Okay. So I need to get the lower bound and upper bound first, don't I?
Mm-hmm.
But for the first one, it says like I have to get like the lower bound of 0. Will that just be like 0?
I think it has to be, yeah. I think that just has to be 0. Yeah, 0 breakdowns.
So 1.5.
Yeah.
And then 1.5. Yeah. So 3.5.
Yeah. Yeah, I think you're okay for those. And what do you do after that?
Do I need to find first of all the middle value,
Mm-hmm.
26? It could be 13.5.
Okay.
And in our little number of breakdowns thing, that'll be in the 0 to 1.5 bracket.
Yeah.
And then is this where I need to use the formula again?
Yeah.
So do I need to do like x minus
So which one matches up with what? So it's from 0 to 1.5. And so it's the median. So the median is between 0 and 1.5.
yeah.
And what do you do? What matches up with what there? Do you know?
So the median. So would the median be like 0.75?
So I believe. Well, what number of breakdowns would it be for the 18th person?
1.5.
Yeah. So those two are matching up, and I think 0 is just matching up with 0.
Yeah.
Or is it, hang on, is it person 1? Person 1 would match up. Yeah. Person 1 had 0 breakdowns. Okay. So I'll try the formula.
And then, so here I need to do x minus, do I need to do x minus 0 over 1.5 minus 0?
1.5 minus 0. And, yeah.
Equals to,
X. And, was it the 13th person was the median?
Is it not 13.5? Not sure.
13.5. Number of breakdowns is discrete data. So I think it would just be 13.
Yeah, yeah. So now I don't need to do 18 minus,
That would go on the bottom, I believe, because that's the total.
is then like 13. I'm not sure what the first value was again.
I think it would be the 13th. 13
Yeah,
minus 13 minus 1.
minus 1. Over 18 minus 1.
Yeah. So what is that?
That is. I got like 1.0588. So 1.1 basically. Or 1.06 basically. But yeah.
So 1.06 breakdowns. So it's I think this might be slightly off though. Maybe I'm wrong because I think we didn't realize it was discrete data until later. Let's take a look. So yeah, it's slightly off 1.08. It's because we didn't realize it was discrete data. No, hang on. 13 minus 0 over 18 minus 0. So they're starting from person 0. That's what it is. That's why the last time we were slightly off because we said it was the third person, but it was the second. It's because you're starting from person 0. That's why. So if that was 0, that's it. Okay, so you're not starting from the first. You're starting from the 0. That's where. Okay. So any questions about that?
No.
Okay, tricky stuff. So sorry to go a bit extra. I just wanted to finish that one. Yeah, how was that for you, Andrey?
That was good, thank you.
So we'll take a look at more of that next time. Any questions for me in general?
No, I don't think so.
Okay. Well done, Andrey. You did great. I look forward to chatting again next time. And I'll send you like all the stuff. And so if you want to look ahead, you can. And if there's some stuff you want to skip, you can.
Okay, thank you.
All right. Have a good weekend. Take care. Goodbye.
You too, cheers, bye.